We will discuss the all detail of the regression analysis in the second term. But now I will give a small introduction to regression analysis for linear and quadratic functions. Price demand and price supply equations can be obtained from the data using the regression analysis. Actually, in the previous record, you can see by using the two value and by knowing the price demand equation is linear, we can calculate or we can find the price demand equation or price supply equation. So we can find the relation between the price and demand by using these two values. But in general, analyzers have the more data. So by using the all values, how we can calculate this price demand equation or this relation. For example, I will try to explain on the following example. Here we have some data for the diamond. Let's read the question. This table gives demand price for round shaped diamonds. Use linear regression to find the best linear model for the form y equals ax plus b. Okay, for the price y in dollars of a diamond as a function of its weight x in carat. So x, this is the x value, these are the x value, these are the y value. So when the carat is 0.5, the price is $2,719. When carat is, for example, 0.8, the price is $4,154, etc. So by using this data, we can find the relation between the price and demand. But it is possible to find this relation as a linear function or quadratic function or another function. Okay. So linear regression produced linear function that is the best fit for a data set. And the quadratic regression produced a quadratic function, second degree polynomial. Maybe you don't know what is the polynomial, but the following videos you will learn. That is the best fit for a data set and so on. So let's look at example 7, this example. Here, example 7 illustrates how a graphic calculator can be used. Actually, in your textbook uses some graphic calculator, but I will explain by using GeoGebra, okay, to produce a scatter plot and a graph of the points in data set and to find the linear or quadratic regression model. Okay, so by using GeoGebra and by using this data, I will show that how you can find the linear and quadratic regression formula or model or function. So first of all, you should enter the all point in the GeoGebra. So 0.5, 2719 is the 1 point on the xy coordinate system. This is x, this is y. 0.6, 3991 is the another point, etc. Okay, so let's enter these points in the GeoGebra. So 0.5, I'm looking at this data from another source, 2719. This is the 1 point. And the second point, 0.6, 3191. And the third point, 0.7, 306.94. That means when the carat is 0.7, the price is $3,694. For 0.8, the price is 4154. For 0.9 carat, the price is $5,018. And last point is for the 1 carat, the price is $5,898. Okay, this is the price. So all of the points can be seen in the graph, but this is not this scaled according to the 1 unit, as you see. So you cannot see that this value is on the graph somewhere far from the origin. So because of that reason, we should fit our graph by clicking the setting and zoom to fit. So these are our point, okay? Our points. So when the cut is 0.5, the price is that 1A. So as you see, this is not scaled now. This length is 0.2, but this length is 1000. So these are our points. So our aim is to find the linear function which is close to these points, or to find the quadratic function which is close to all these points. So how we can find? By using the fit line command. Fit line, from here you can choose, and fit line list of the points. So by using this expression, we can find our point. If you want, you can take that from this question mark. So our points are A, comma, B, comma, C, comma, D, comma, E, comma, F. So these are our points, okay? So this formula, y equals 6137 blah 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 x minus 478.19 is our linear function. This is represent our data. As you see, not all points are on the line, but these are very close to line. So this is the best line. The differences between the f and this value and this value, what which value, maybe I can explain. In the second term, we will discuss all details, but the a value is the exact value, so 5818. But for x equals 0.9, you can find the y value on the line. So this is the approximate value. So difference between them will be called the residue. In the second term, you will see. So the summation of these differences is the square of the summation of these differences is the smallest for this line. Okay, so this is the best fit line. In your textbook, you can see the coefficient here, which are the same. 6137.42 blah 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 minus 478.19 blah blah blah. Okay, so you find the same value. How you can find the quadratic approximation of quadratic regression? Now you should use again fit polynomial, not the line. With fit polynomial, you don't know maybe polynomial, but in the following videos you will see. And the quadratic function is the polynomial with the degree 2. So from here, by writing list of the point and putting comma and writing the degree as a 2, you can find the quadratic approximation. So A, comma, B, comma, C, comma, D, comma, E, comma, F, and we should write the degree. Degree is 2. So this is the second degree approximation, quadratic approximation, quadratic regression for the data. Okay, so let's look here. The green curve, the parabol, is the fit our data. Let's look differences between the points and the polynomial and also line, parabol and line. So the exact point is that one. Approximate point for the quadratic approximation is this value, that some value of some here. But as you see, this is far from the point exact value of the a. Okay, so you can compare it if you want. What is the f of 0.5 value, which is, I could not see here. Maybe I can see. Okay, I could not see, but I try to show that. For the 0.5, this is approximately 2060. Exact value is 2719. 2600, okay, approximately. For the quadratic approximation, it is 2810, etc. So it is close to that value. And for the B, let's look for the point B. Now, linear regression gives us the better approximation for the point B. Quadratic is a bit far from the this point value, this value of the B. Okay, but for the other points, for the point C, quadratic is better because this is closer. This value is closer than the closer to the point C than this point. And D again is the better. Quadratic is better for the point D. For the point E again, quadratic is better. For the point F, quadratic is better again. So according to this 5 point, we can say that quadratic regression give us the better approximation to the our data. How we can use these two functions? For example, let's predict the price when the carat of the diamond, the weight of the diamond is 1.1. So f of 1.1, this is the prediction of the linear regression, is 6272. So this says if you use the linear model, linear regression, you can predict the price of the diamond with the 1.1 carat is $6,272. By using the quadratic regression, G of 1.1, okay, let's look this value. So quadratic regression analysis says the price will be $6,900. Okay, so there is a big difference between them, but we observed that quadratic approximation is better. So quadratic regression analysis is better than the linear regression. So most probably the price of the diamond will be this one according to this table value. So regression analysis is very important for this course and also for your area, and it can be calculated easily by using GeoGebra by this way.